Okay, so part C, determine the length of time in the afternoon for which the depth of the water in the harbour is more than 9 metres. Now you've got to be careful here, okay, but again go back to our diagram. If the depth is 9 metres, let's just consider it when it is 9 metres, and we can find the times there where it's exactly 9 metres, and then we can deduce when it's more than 9 metres. But be careful, we're not going to set x to equal 9, right? Remember, x is measured from here, yeah, from the center of our oscillation. Okay, if the depth is going to be 9, well, of course, we've got all of this first of all, so that's going to be 3 there plus 4, so that takes me to 7 meters already. So I'm already starting at 7 meters here. So to get a depth of 9 meters, I need another 2 meters on top, yeah. So x is going to be 2. That's what we're going to set x to be. So if you see that clearly there, the depth of water is 9 meters, you've got 7 meters there to the center of oscillation. So that means then for a depth of 9, x needs to be 2 to take us up to 9. So we can put that in there. So then if we go back to our expression for x, all right, we can then so we've got x equals 4 sine pi over 6t. So then we can put 2 in here, equals to 4 sine pi over 6t. What I could do then is I could take the 4 over, so it becomes 2 over 4, okay, equals sine pi over 6t, and of course then you take the sine over, sine to the minus 1, so pi over 6t equals sine to the minus 1 of 2 over 4, okay, so pi over 6t then will equal, well, the result for that will be, if you use your calculator, it comes out to be pi over 6, because that's a half, and sine to minus 1 over half is 30 degrees, or pi over 6. Make sure it's in radian mode. Now you've got to appreciate that that's just one result. Of course, if you draw your sine graph, you get other results out. Okay, I only need one more result. If we think about the sine graph, okay, sine to the minus 1 of 2 over 4, that's a half, isn't it? So half's about here. Okay, so pi over 6 will be this result here. But there's another result there, yeah, where it's equal to half. So how do I get that? Well, if you remember, that's 0 degrees, that's 90 degrees, which is pi by 2, and then that's 180 degrees, which is pi. So you've got pi there. So if you've got pi, and you've got to go back pi by 6, so pi, take away pi by 6, that'll be 5 pi by 6. Okay? And then you can work out your times, right? So let's work out the first time. Pi over 6t equals pi over 6. So what will happen here is that the pi over 6's will cancel, so that means t is equal to 1. And then the next time you'll have pi over 6 here, so I take that and then equal that to 5 pi over 6. Okay, so the pi's cancel, and the 6's cancel as well. T actually is 5 hours. So we can say it is at a depth of 9 meters between t equals 1 and t equals 5. So then for it to be above 9 meters, you can see then it's above 9 meters for that gap there of 4 hours. So it is above 9 meters for 4 hours in total. Okay, now then part D, it says find the depth of the water in the harbour when the rate at which the level of water is rising has a magnitude 0.4 pi meters per hour. So read that question carefully, okay? It says when the rate, yeah, at which the level of water is rising. So remember, the level of water is measured by x, isn't it? Yeah, the level of water. So we get the level of water. But when they look at the rate of it, that's then how it's changing, yeah? So how rate of change of x, that's what we've got to think. So dx by dt, in other words, the velocity. Okay, so when they say the rate of the level of water is rising by this, essentially the velocity is that. Okay, that's what they're telling us there. Okay, so v is 0.4 pi. Okay, now we can use then our formula for v. Okay, so v squared equals omega squared, bracket a squared minus x squared. Now we know, we've told that v is 0.4 pi. Omega, well, we worked that out earlier to be pi over 6. A, the amplitude is 4, and then from there then we can get our x, okay? So we can simplify all that down. Now, I've done this earlier, so if you work that out, right, you end up having x squared to be 10.24 meters, okay? And you need to appreciate then that you're going to have two answers, yeah? Because when you square root, you have plus or minus, okay? So that means x is 3.2 meters, or x is minus 3.2 meters. So again, then it goes back to our sketch to see what the depth is going to be. So if x is 3.2, okay, we need to appreciate then positive 3.2, so it's 3.2 up here, but we need to add it on to the water depth there, which is already 7 meters. So 7 meters add 3.2 will be 10.2. The depth will be 10.2 meters. Or if it's at minus 3.2 meters, we've got to go down 3.2 meters, which will take me to about there. And the easier way to do this is to think of the whole height there as 7, okay, and then you take away that 3.2. So 7 take away 3.2 is 3.8 meters. So at those two depths, the velocity will be 0.4 pi. The level at which it's changing will be that speed there. The rate at which the level is changing is 0.4 pi.